Okay, so tell me if this sounds familiar.
Hmm.
You're you're getting ready to head out the door,
Yeah.
and you've already checked the weather app like twice,
Right.
but you can't help yourself. You just have to check it one more time, just to be sure.
Oh, yeah, absolutely. I do that all the time.
It's like this weird obsession with knowing what the sky has in store.
Totally.
And that's exactly why we're diving deep into the world of weather systems and forecasting today.
Yeah, it's fascinating stuff.
We've got our trusty weather analysis textbook, a lesson plan on weather systems,
Okay.
and some serially cool diagrams to guide us through this.
Sounds good.
By the end of this, we'll all be speaking the language of weather like pros,
I love it.
deciphering those forecasts with confidence.
That's the goal.
So let's start with the big picture. What exactly is weather forecasting, and why should we even care?
Well, it's essentially trying to predict what the atmosphere has planned.
Like,
It's like trying to read the mind of a very complex and often unpredictable system.
and it's not just about knowing whether to grab an umbrella or not, right?
Right. Our sources really highlight just how vital accurate forecasting is.
Mhm.
Think about it. Agriculture, transportation, even disaster management all hinge on knowing what the weather has in store.
It's true. I mean, imagine a farmer planting crops with no clue about an impending drought,
Exactly.
or airlines navigating through storm clouds without any warning.
Exactly. Those are just the tip of the iceberg.
Yeah.
Disaster management relies so heavily on timely and accurate forecasts. Those early warnings about hurricanes or blizzards are lifesavers, literally. So understanding how those forecasts are made and how reliable they are, it's pretty crucial.
Now, speaking of decoding the weather, our sources mention this thing called the station model.
Oh, yeah, the station model.
It sounds kind of mysterious.
A little bit, yeah. It's essentially a weather report condensed into a single information-packed symbol.
So kind of like a weather whisperer's cheat sheet.
Exactly. You've got a circle representing the station's location, and around it you'll see numbers for temperature dew point lines showing wind direction and speed, and symbols for cloud cover, pressure, precipitation. It's incredible how much information they pack into that little symbol.
So it's like a secret weather society handshake.
Yeah, kind of.
But once you're in the know, you can unlock all these secrets.
You're speaking my language.
Now let's talk about how meteorologists actually paint those future weather pictures, because we've got the tools to understand them now.
Right.
Our sources delve into two main methods: analog forecasting and digital forecasting. So
Yeah.
what's the difference?
Well, imagine this. You're trying to predict tomorrow's weather.
Okay.
So you pull out your trusty weather journal from, years past,
Okay.
and you start flipping through, looking for days with similar starting conditions, like temperature, wind direction.
So you're searching for a weather doppelganger.
Yeah, essentially you're saying, okay, it's a Tuesday in October, it's kind of chilly, and the wind is blowing from the east. Has there ever been a day like this before?
And what happens next?
You study what happened on those similar days in the past and use that as a guide to predict what might happen tomorrow.
That makes sense, especially for short-term forecasts.
Right. But as our textbook points out, it relies so much on finding those perfect matches from the past.
It does.
And the atmosphere is a fickle friend.
It really is.
So I imagine that's where digital forecasting comes in.
Exactly. This is where we enter the world of weather forecasting 2.0.
Ooh, fancy.
We're talking sophisticated computer models,
Okay.
crunching colossal amounts of atmospheric data. Temperature, pressure, wind moisture, you name it. It's all in there.
So instead of flipping through old weather journals,
Right.
we've got these powerful computers simulating the atmosphere itself.
Exactly. It's like having a crystal ball, but instead of vague predictions,
Right.
we get detailed breakdowns of potential weather scenarios.
And our textbook really highlights how much more data this method uses.
It's incredible the sheer amount of information they can process. So it's not just about looking for those one-to-one matches from the past.
Yeah.
Digital forecasting is analyzing all these intricate details.
It's about connecting the dots on a massive scale. And the beauty of it is that it's constantly evolving, becoming more sophisticated and precise all the time.
So we've got our forecasting tools, but now we need to meet the stars of the show,
Let's meet them.
the weather systems themselves.
Yes.
Those atmospheric heavyweights, calling the shots, determining whether we get that sunshine, rain, or snow.
It's all about them.
High pressure systems, low pressure systems, and of course, the dramatic encounters of fronts.
Where the real excitement happens.
Exactly. So let's start with the life of the party high pressure systems,
Okay.
the bringers of those clear, sunny days we all crave.
Right. Picture this dense, dry air gracefully sinking towards the ground. And as it descends, those air molecules, they spread out.
So there's no room for clouds to crash the party.
No clouds allowed.
My kind of gathering sunshine and good vibes only.
Exactly.
But what about when the party gets a little wilder? That's where our low-pressure systems come in, right?
Exactly. Low-pressure systems are like that friend who always brings the excitement, sometimes a little too much excitement.
Okay, I'm intrigued.
Think of less dense, moist air rising like a hot air balloon.
Okay.
As it ascends, it cools. And that's when the water vapor condenses, forming clouds.
Hmm.
And we all know what happens when those clouds get too full.
Let me guess, downpours, maybe even a thunderstorm or two.
You got it.
Yeah.
They're the ones keeping things interesting, that's for sure.
And then we have the clash of the Titans fronts.
Oh, yeah.
These are the boundaries between those very different air masses, right?
Precisely. It's where the real action unfolds. Imagine cold air masses and warm air masses locked in this constant battle for dominance. This clash of personalities, it leads to those rapid changes in temperature, wind, and precipitation.
It's like a weather soap opera up there.
The drama is real.
So let's break down this meteorological drama. We've got cold fronts, warm fronts, occluded fronts, and stationary fronts.
All battling it out.
I always feel like I need a flowchart for this part.
Yeah, visualizing it definitely helps.
Okay, so first up, cold fronts.
Right.
Lay it on me.
Imagine a bulldozer of cold air just plowing through a region of warmer air.
Oh, wow.
That denser cold air wedges itself underneath, forcing the warm air to rise abruptly. And that right there, that's your cue for some intense weather.
Intense how so?
Heavy rain, thunderstorms, maybe even some snow depending on the season.
Talk about a dramatic entrance.
They don't mess around.
And our lesson plan mentions these cold fronts also bring a dramatic temperature drop
Oh, yeah?
and winds that'll ruffle your feathers.
At least mess up your hair.
Exactly. Now, what about warm fronts? Are they a bit more gentle?
They're all about subtlety, not
Mhm.
shock and awe. They bring high humidity and generally stable air, like settling in for a cozy, slightly muggy afternoon.
Okay, so instead of a dramatic downpour, a warm front is more of a light drizzle kind of day.
Precisely. Think light rain, maybe some drizzle, and a gradual increase in temperature.
I'm picturing a comfy hammock and a light sweater.
There you go.
Much calmer than the bulldozer scenario.
That's calmer.
But what about occluded fronts? They sound a bit more complicated.
They can be. It's kind of a three-way standoff.
The three-way.
It's what happens when a fast-moving cold front overtakes a warm front, kind of like a weather version of Capture the Flag. The warm air gets sandwiched between the two colder air masses and lifted away from the surface.
So it's like a multi-layered weather cake,
I like that.
but instead of frosting, we get, what exactly?
It depends on the players involved. Occluded fronts can bring a mix of weather conditions depending on the characteristics of the different air masses. Think of it as a weather surprise bag. You never know what you're going to get.
Intriguing. And finally, we have stationary fronts.
Right,
These are the ones that just can't seem to make up their minds.
pretty much. It's a standoff between a cold air mass and a warm air mass, but neither one has enough oomph to push the other one out of the way. They're stuck in a holding pattern.
So instead of a dramatic change, we get the same weather on repeat.
You got stationary fronts can bring days of cloudy skies and persistent precipitation. It's like the weather is hitting the snooze button.
Okay, so we've explored these localized battles of air masses.
Yeah.
But what about the bigger picture? The global forces directing this entire atmospheric orchestra. I'm talking about global wind patterns, those massive rivers of air constantly circling the globe.
Now you're talking my language.
Right. It's like zooming out to see the entire weather map of the world.
Exactly. These global winds are like the conductors of the weather orchestra, influencing everything from our daily forecasts to those long-term climate patterns.
And one of the most influential players has got to be the jet stream.
Oh, absolutely. The jet stream is a major player.
I mean, I've definitely heard of it. Isn't that the one that impacts air travel? Like a super highway in the sky for airplanes?
You got it. It's like this fast-moving river of air way up high in the atmosphere, zipping along from west to east.
Okay.
That's the jet stream in a nutshell.
Oh.
But it's not just any old air current. It's like a giant meandering river in the sky.
Okay.
And it's dividing those warm and cold air masses, steering storms, and even influencing our temperatures down here on the ground.
So it's like a puppeteer.
Kind of.
But instead of strings, they're using wind.
Exactly. And get this, there are actually different types
Wow.
of jet streams.
Really?
Yeah, we have the polar jet stream, which whips around the globe at higher latitudes.
Okay.
And then there's the subtropical jet stream, which hangs out closer to the equator.
So it's like a two-lane highway in the sky,
Yeah, I like that.
each lane influencing a different part of the world.
Exactly. Each jet stream influences the weather in its own way, playing a role in shaping storm tracks, temperature patterns, even those occasional weather anomalies we sometimes experience.
So basically the jet stream is just messing with us.
In a way.
Yeah,
But hey, it keeps things interesting, right?
I guess so. But this atmospheric highway isn't the only player in the global wind game, is it?
Oh no, definitely not.
What about those old sailing tales of trade winds? I'm picturing like old-time explorers with those big billowing sails.
Ah, yes. The trade winds, those steady winds have been blowing ships across the oceans for centuries.
Right.
They were the original transatlantic highways powered by the sun and Earth's rotation.
That's so cool. It's amazing how these winds shaped exploration and trade routes.
It is fascinating, isn't it?
But what makes them so reliable? Our sources mention something called the Coriolis effect. I've heard of it, but I could never quite explain it.
Right, the Coriolis effect.
Hmm.
Okay, so picture this, the Earth is spinning.
Okay.
Well, that spinning creates this apparent force.
Apparent force.
Yeah, it's a little weird, but bear with me. So this apparent force, it deflects moving objects like winds to the right in the northern hemisphere and to the left in the southern hemisphere.
So it's like trying to walk in a straight line on a spinning carousel. You end up like veering off course.
Exactly. It's like
Huh.
the Earth is playing a giant game of curveball with anything that tries to move across its surface.
Okay, so that's the Coriolis effect in action. But how does that create the trade winds?
Okay, so we've got the spinning Earth, right?
Yeah.
And then you factor in the uneven heating of the Earth's surface.
Because the equator gets more direct sunlight.
Exactly. So you've got warmer air rising near the equator, and then cooling and sinking as it travels towards the poles.
Okay, I'm following.
And as that air moves, it gets deflected by the Coriolis effect, creating these consistent easterly winds near the equator.
Those are our trade winds.
Boom. Trade winds.
That makes so much sense. So we've got the jet stream influencing things at mid-latitudes,
Right.
the trade winds keeping things moving in the tropics.
Yeah.
What about those polar regions? It's got to be pretty windy up there.
Oh, you bet it is. In the
Yep.
polar regions, we've got the polar easterlies.
Polar easterlies. Okay.
Remember how we talked about that warm air rising at the equator?
Yeah,
Well, that air eventually cools and sinks.
makes sense.
Where does it sink? The polar regions.
Oh, right, because cold air sinks.
Exactly. So you've got these areas of high pressure forming in the polar regions.
Okay.
And that sinking air, it flows back towards the equator, and as it does, it gets deflected by, you guessed it, the Coriolis effect.
Of course. Always the Coriolis effect.
Always. And that creates those chilly easterly winds that sweep across the polar regions.
So it's like a giant loop.
Right.
Air rising at the equator, traveling towards the poles, sinking, and then flowing back to the equator.
It's like a global air conveyor belt.
I love it. And that's not all, is it?
Nope. We've also got the prevailing westerlies.
Prevailing westerlies, what are those?
These are the winds that dominate the mid-latitudes.
Okay.
They blow from west to east, just like the jet stream,
Okay.
but they're found closer to the surface.
So kind of like the jet stream's little sibling.
Exactly. The jet stream's slightly slower, more grounded sibling.
I like it. So we've got this intricate dance of winds,
We do.
all influenced by the Earth's rotation temperature differences and those pressure systems we talked about earlier.
It's all collected.
It really is mind-blowing when you think about those massive rivers of air
I know, right?
constantly swirling around the planet,
It's amazing.
influencing everything from our daily commutes to the delicate balance of our planet's climate.
Exactly. It's about understanding the present, but our sources also talk about the future of weather prediction.
Oh, right. How technology might change things up a bit.
Exactly. We were going to get to those questions about weather modification technology.
It's pretty wild to think we might be able to influence something as powerful as the weather.
It's a big idea.
It is. But before we get ahead of ourselves,
Let-
let's recap what we've learned about how weather forecasting works right now.
Good idea. So we started by cracking the code of the station model, that clever little symbol that's like a weather report in shorthand.
It's like the emoji of the weather world.
I love it. And then we talk about those different forecasting methods, analog and digital.
Analog being the history repeats itself approach.
Right. Using those historical weather patterns to predict the future.
And digital forecasting. That's where we bring in the big guns,
The computer models the mountains of data.
simulating those complex atmospheric interactions.
And then, of course, we dove into those incredible weather systems, those high and low pressure areas, the dramatic fronts, all waging their little weather wars above us.
It's like a never-ending weather drama unfolding right over our heads.
And finally, we zoomed out to appreciate the global forces at play.
The jet stream, the trade, winds the polar easterlies, those prevailing westerlies.
All working together to shape weather patterns across the globe.
It's mind-boggling to think about. It really is.
It is fascinating.
But as we delve deeper into these weather mysteries,
Yeah.
it does make you wonder, how much of a role will we play in shaping the weather in the future? It really does make you think.
It's a huge question, right?
We've gone from relying on the wind to carry our ships to thinking about harnessing it to, like, control the weather.
And that's what those questions from the lesson plan really get at.
Right, like who gets to decide what the perfect weather is?
Exactly.
What's considered too hot or too cold on a global scale? And then there's the whole butterfly effect thing, right?
Oh, yeah, the ripple effects are huge.
What if trying to make it rain over here
Right.
causes a massive drought over there?
Exactly. It's a game of atmospheric dominoes, and we don't really know all the rules yet.
It's kind of a lot to think about.
It's complex.
Yeah.
It really is. But it's a conversation we need to have because we're learning more about the weather and climate every day.
Absolutely. We've come a long way from just looking out the window and hoping for the best.
That's for sure.
Well, on that note, we always like to leave our listeners with a little something to ponder,
Okay.
a thought to spark their curiosity.
I like it.
So we've talked about these massive weather systems, global wind patterns,
Right.
the potential for humans to maybe someday influence the weather.
It's a lot to take in.
It really is. But here's something a little closer to home.
Okay.
What if you could become like a weather detective in your own backyard?
I love that. Tell me more.
So next time you're outside, really take a moment to observe the weather around you.
Okay.
Feel the wind on your face. Notice the clouds, their shapes, how they're moving.
I like it.
Can you tell which direction the wind is blowing? Are those high, wispy cirrus clouds or those puffy cumulus clouds that might bring rain?
You're turning everyone into amateur meteorologists.
That's the idea. It's like putting all this newfound weather knowledge to the test.
It's a fun challenge.
Exactly. You might even start to notice those subtle shifts in the air, those little changes that signal a shift in the weather.
It's like you're becoming attuned to the rhythm of the atmosphere.
Exactly. And who knows, maybe you'll even surprise yourself with your newfound weather forecasting skills.
I love it.
But for now, we're out of time for today's deep dive.
Time flies when you're talking about the weather.
It really does. But hey, there's always more to explore.
Always.
So until next time, keep your eyes on the skies.
And your weather journal's handy.
You never know what we'll uncover together in our next deep dive.